Hi, welcome my awesome students. So we took a look at how to create format specifiers, data types, and there's a couple other things that we have done, which is super cool. We are progressing here, guys, even if it's one lecture at a time, right? You can't really do everything at once. So anyway, so let's talk about variables, right? Variables, you know, in the C programming language is just like in any other language, okay? Contain data that we can use, but in C we have to specify a type of data that that variable is going to have. For example, this name variable is going to have a string or a character, if you want to call it that, because I am declaring it with a data type of char. Okay, now I can also declare other types of variables like the number there. All right, you can also assign a value to it right away. So I can say, well, this variable, let's just say float the pi, and we're just gonna say 3.14. Simple as that. Okay, and you can grab that variable, of course, and change it to something else, to say 200, for example, or 200 point whatever 45. And then you can come here to print f, to the printf function, say, hey, this is the value. And I'm just going to put the pi. Make sure you put your format specifier here. And this is a float. So we're going to say format specifier %f because it's a float. And now if I run this, you can see it says this number is pi 3.45, and it's going to print out all the other stuff that I got here, which I don't want, right? I'm going to run this again, and it says, hey, this is the value, 200, whatever. And then 6 spaces after. Okay? So pretty awesome, right? That's variables. That's super simple. You learn that in the programming fundamentals or you know, and that's where you actually learn this, when you're learning the programming fundamentals of, you know, programming, the fundamentals. Anyway, so let's talk about constants real quick. Let's learn about how we do that in the C. And very similar to other languages, we use a const keyword, okay? Then after this keyword, then we define the type, okay? I'm going to define a constant that is going to be an int. And I'm just going to put here initial val for value. And then I'm going to initialize it with a number of 20. Simple as that. Okay. Now this will make it a constant. Now if you try to give it another value somewhere else, I'm just going to put a different number, right? And then you try to print it out or something like that, you're gonna get an error. My IDE is gonna catch up to this and give me some type of error here. I'm just gonna make sure that format specify is a int or data type D. A format specify is D, %D. So now if I try to, you can see now that it says error exists in required project. Continue to launch? No, I want to take a look at the errors, and it says here, cannot assign a variable initial val with const qualified type. Okay? Simple as that. Type const int. So now it's saying that, now if I go ahead and play this now, we should see this is the value 20. You see that? So now it's working. So you cannot assign another value, just like in any other programming language. That's the way you do it here, okay? So we took a look at variables and we took a look at constants. Pretty awesome. In this lecture, I'm just going to leave it the way it is. And let's go ahead and continue learning in the next one. Take care, guys. Welcome, my awesome students. So in this lecture, we're going to take a look at arrays, all right? We already did variables and constants. Let's take a look at arrays. So to create arrays in the C language is very similar than in other languages, okay? So let's take a look real quick here. I wanted to dedicate a lecture for this because it's super important for you guys to understand it. In C, it's similar creating an array than we do in the JavaScript or PHP, but it also is a little bit different. Besides that, we have to declare a type of array. You know, sometimes we can also give it a number of elements that we want in a specific array if we wanted to. And let me show you. And we also use other syntax that is a little bit different when we are assigning values. Let me show you. So let's talk about declaration real quick. Declaration. And this is how we declare a array here. And let's just say, let's just call it this array just to, okay. And let's just give it a value here. Let's just say 5. So basically here we are specifying an array with 5. Okay. So we're saying, hey, listen, you can only fit or put 5 elements into this array, right? Let's go and do this without specifying any value and see what it does. If we don't specify anything here, well, let's just go ahead and use the curly brackets, because that's how we assign some values to this array. Let's just put some numbers here. Let's just say 45, 67. I don't even know where I'm getting this number. And let's just say 4. Simple as that. So what we're saying here, okay, what the compiler is going to do is going to see this empty and is going to say, okay, I'm going to assign 4 to that. Simple as that. Okay? Simple as that. That we create an array of size 4. So let's just leave it empty like this. And let's talk about, and this is, you can put this initializing here, something like this, initializing. Okay. Perfect. You can also go ahead and grab one of these values. For example, let's print out, let's do this array value, array index value is, and then you can grab the array here. Let's just grab it. And you can say 1, 2, 3. One, two, three. Let's just say that would be number. Let's see what it happens here. So right now we need a format specifier here, and we need to say that would be an integer or something like that, right? So we put a D, save it, and let's put a comma here, of course. There we go. It's gone. This is gone. And now we compile this, and you can see now, let's just cancel this guy out. And let's cancel this guy out. And let's save it and compile it again. And you can see now that it says, hey, this array index value is 0. What about number 3? And I'll explain in a minute. If I do that, it says value is number 3. Now, this array always, okay, if you go over it, if you go over the spaces, is going to say, well, we don't have any more spaces, and so it's going to be 0. But remember that it starts at index 0. Okay, so right now it's at index 0, 0. So 0, 1, well, 1, 2, 3, 4. Well, 0, 1, 2, and 3. So if I say 0, it's going to give me 45. Okay, 0 base arrays. Okay, 0 based. Okay, so now I can go ahead and, if I wanted to, I can grab this array, and instead of having the 45 in the first spot, I can change it to 100. So I can go ahead and print this thing out here and run it, and you can see now that the second here value is 100. Let's put a new line here, and that should make a new line. Let's see. There we go. This array index is 100. So you can change the value by assigning it. See, grabbing that index, which is 45, assigning a different value to it. Okay, pretty awesome. So you can do that with everything you want, and you can keep, putting more specifiers. So you don't have to put a comma, but different specifiers and different values here if you want to grab those values. All right, and this is how we go ahead and declare arrays with no values at all. That would make the compiler actually put the amount of elements that you have by themselves, or you can give it an amount of elements that you want in that specific array. Okay, you can assign values to other indices. You can basically change them. And later on, we're going to show you some more examples with arrays and loops and all that. Okay, thank you so much, and I'll see you in the next lecture, guys. Take care. In every programming language, we have numbers, and we have to find a way to deal with those numbers. For the C programming language, like in many others, we have operators, arithmetic operators. That's what they're called, and I have a really, really hard time saying that word. Arithmetic operators, because we have other operators, but we're going to take a look at the math operators. Okay, and they're very similar than we have in other languages. I'm going to go ahead and define some variables here just to show you an example here real quick. Increment and decrement, and modulus. I want to show you how you do it in Z. Well, 9Z in C. Actually, modulus, just like that. All right, just getting my facts straight. Okay, so if I grab the sum variable and I can add a 5 plus 5, doing that, and just the same thing as math. Okay, that's what the symbols are. Minus, subtraction. We have division with a forward slash, same thing as other languages, and asterisk for multiplication. Okay, now we can also, we also have the modulus. And how do we do the modulus? Well, the modulus is super simple to do. Let me first show you real quick how that this is working, is actually adding it. Okay, so if I take the last one here, and this is an int form a specifier, so the calculation is if I go ahead and do this, let's take a look. Expected expression. So we'll take a look at that. Print F, the calculation is, it should give me that percentage D. That should be good. And let's look at what it's telling me. That error doesn't, it's telling me that it does have a problem, and this is because this has a problem here. There we go. Now that that's over with, let's go ahead and say, well, the calculation is 25 because the last value here was 5 times 5. Okay, so you see that my calculation is actually working here. Let me show you the modulus. All right, the modulus, just like in any other language, is super simple, and we're gonna do a calculation real quick here. So I'm gonna grab this and I'm gonna say modulus is equal to, let's say, 10, and then we put the modulus operator here, which would be the percent, and we're gonna divide it by 3. Now we are gonna grab the modulus and we're gonna print it out and show you what we are talking about. And let's just grab modulus real quick here. So I'm going to explain to you what modulus is, just in case you don't know, but this is how, once you have the calculation here. So the calculation is 25, it says here, and the calculation is 1. Now this last calculation here gave me 1. And can you guess why? Well, 10 divided by 3 is actually not exactly one number, right? 10 divided by 3 will give you like a 3 point something, right? But if we do the calculation by hand, like old school, we see that we have a remainder of 1 because 3 fits into 10 3 times and there has 1 left over. Okay? So that's what that is. Modulus is the remainder of that division here. Okay? Simple as that. Now let's also do the decrement because I want to show you that. There are plus and minus, which we have in other languages, and it's, guys, it's the same thing as other languages. I just feel like I need to show it to you here. So if I do increment and then I do plus sum, and then I do decrement here and do minus. And if I go ahead and print this out real quick here, and let's do with the increment first. Let's see what we get. Let's play this, and it says 26. Remember that the sum last value was 25 here, 5 times 5, so it incremented 1. Now let's do the decrement and see how that works. Save the file. Remember that it says 25 now because we are incrementing some, but we are decrementing in there. So let's comment that out and let's do that now so you can see it clearly. It decremented the 5 times 5 that's here to 24. So it increments by 1 and it decrements by 1. Okay, so that's it. That's it for arithmetic operators. You're welcome to play around with them a little bit, but they are the same in every language, in most languages. Thank you so much, and I'll see you in the next lecture. Hi, welcome, my dear students. So in this lecture, we're going to take a look at logical operators, or sometimes called relational operators in the C language. Okay, so let's go ahead and I'm going to comment this out real quick. And we're going to take a look at relational operators, or logical, as I like to call them. Logical operators. Okay, super simple, super cool. All right, so let me just go ahead and define real quick something here. Let's just do something like let's just do y. Usually you see this in university courses where they use the x and y's. So we're gonna do that here, even though this is not a university, but you know, giving you some tips for those of you that have never been into one or never take any programming course in one. All right, so let's do some operators, and this is what they are. Okay, I'm gonna give you a really cool summary here. I'm assuming the reason why I'm not explaining to you what each of them will be is because you're supposed to know this. This is programming fundamentals, but I'm gonna go to over a couple of them. This is the not operator. Not. This is the equal. As a matter of fact, I'm gonna do this really fast, so you don't have to watch me do this. All right, so I just wrote all that down while the video was paused, so that way you guys can get a pretty good idea. This is a not operator. This is the equal, not equal, greater than, smaller than, greater than or equal to, smaller than or equal to, the and the or. This is the same thing in many programming languages. And let me just give you an example real quick. I'm going to do one right here. I'll show you real quick. And I'm just gonna say, so printf, I'm just gonna say something like if x is basically x equals y, and then we just go ahead and print the x here. Let's just put a parenthesis here like that to execute this and say equal y, just like that. No errors. Okay. Make sure we put a %d here, a format specifier, and let's just do another line here, and let's just go ahead and, well, we got to save that. Make sure you save it. Let's see what we get here, and you can see now that it says 0 here. So basically x is not equal to y. Okay, this is going to give you either a 0 or a 1. So 0 would be false and a 1 would be 0. I mean, a 0 would be false and a 1 would be true. Okay, so that is what this is going to give you back. So let's do it again so that way you can see it. Yeah, we'll save it, and you can see now they said 0 is, okay, let's just save it, and so is x equal to y, 0. Simple as that. Okay, and then you can do the rest if you want. Let me show you the opposite of that. So right now what I'm gonna do is I'm gonna put a not operator here. All right, and if you can see that it says 1 because that one passes, is not right there, and you can see that that one, it passes because it's true. X and y are not equal, so that's why it passes. And you can try all of them. You have them right here. You can keep trying and you're gonna get either zeros and ones because 0 is false. And I'm gonna put that right here. 0 in programming is false and 1 is true. Okay, simple as that, guys. And this is what logical or relational operators are, and this is how we use them in C, just like in any other languages. Thank you so much, and I'll see you in the next lecture.